Hi everyone, welcome back to CCPLUS. My name is Abhi Agustin. So today we are going to discuss about a theorem connecting, a problem connecting chords, segments and a circle. So we should know what is a circle. We all know different definitions for circle, right? Circle is a collection of all points which are equidistant from a fixed point, right? Then move on to a chord. What is a chord? Chord is a line segment. Chord is a line segment connecting any two points on a circle. Okay. Then the last idea, segment. What is called a segment? Segment is a region enclosed by an arc and a chord. Obviously, we should recall the idea arc. What is an arc? Arc means a part of a circle is called an arc. So, mainly in this problem, we are discussing or we want to know the definition of a circle, chord and a segment. Okay? Come, let's discuss. If two equal chords of a circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of other chord. So, before move on to the solution or before move on to the proof, we should draw the figure. Okay, we are talking about two chords of equal length. Okay, they intersect within the circle. So, we can draw the picture. A, B, C, D are two chords of equal length. We want to prove that they intersect within the circle. Let E be the point of intersection. We can mark O as the center. Okay. We need to prove that the segment of one chord is equal to the corresponding segment of the other one. Okay. For that, we want to prove that AE is equal to EC or CE and DE is equal to EB. Okay, so we want to prove that AE is equal to CE and DE is equal to BE. So, this is the result that we want to prove. Okay, for that, first we will draw perpendiculars from the center O to the chords. Okay, and we will join these two points OE. So, this is the construction we did, which means OM is perpendicular to AB and ON is perpendicular to CD. Okay, so we are focusing on these two triangles. Okay, is it clear? So, we are taking or we are considering triangle OME and triangle ONE. Okay, so we are focusing on triangle OME and triangle ONE. Here, our aim is to prove these two triangles are congruent. Okay, so focus on the picture. These two lengths are equal. Why? We know the distance from the center to equal chords are equal, right? The distance from the center to equal chords are equal. Question, it is given that the chords A, B and C, D have the same length, which means they are in equal length, right? So, OM and ON denote the distance from the center to the chord, which means they are equal. So, we can write OM equal to ON. And by construction, we know angle M is equal to angle N is equal to 90 degree. So, which criteria we are focusing? We are focusing RHS criteria, right? So, we got one side of two triangles are equal. Then, we are focusing on the third side, which means this is the third side, which means if we observe they are common and that is the hypotenuse of both the triangles, right? Which means OE is equal to OE. So, what is RHS rule says? RHS rule says that for a right angle triangle, if the hypotenuse and one side of one right angle triangle is equal to hypotenuse and side of another right angle triangle, then we can say that these two triangles as equal. Triangle OME, not equal, OME, congruent to triangle ONE. Okay. So, we got OME congruent to ONE. We know that corresponding parts of CPCT, we learn the result. Corresponding parts of congruent triangles are equal, right? So, if we observe, we can say that ME is equal to NE, right? ME is the third side of first triangle is equal to NE, the third side of the second triangle, right? So, by CPCT, we can say that ME is equal to NE. So, if we add AM on both sides, if this is equation number 1, okay, if this is equation number 1, if we add AM on both sides, what will we get? AM plus ME is equal to AM plus NE, right? What is AM plus ME? Instead of AM plus ME, we can write AE, which is equal to, we know that AB and CD are equal chords. AB is equal to CD, that is given in the question. If we take half of AB, what is half of AB, which will be equal to half of CD? Half of AB is AM, right? Which is equal to half of CD is equal to CN, because by construction. Okay. So, instead of AM, if I write CN plus NE, look at the picture, CN plus NE, we will get AE equal to CE. Back to the question. This is the first result that we want to prove. AE is equal to EC. Then the second result that we want to prove is, I will write here, DE equal to CEB is equal to DE. Okay. So, here AB can be written as AE plus EB, right? We know AB equal to CD. AB can be written as AE plus EB, which is equal to CD can be written as CE plus DE. CE plus ED, right? So, if we observe, we prove AE and CE are same, right? AE and CE are same. If we have the same term on the both sides of an equation, we can cancel the term. Okay. So, here AE and CE are same, of same sign. We can cancel the terms on both sides. So, what will we get? We get EB is equal to ED, which means the second result. Okay. So, first we start from the given idea and we prove the idea that we want. I hope the idea is clear. We are providing record classes for both NCERT and SCERT students for the class 5th to 10th. So, hurry up, go to Play Store and download the app CCPLUS. For more details, contact to this number. We can see you soon on next video. Bye-bye.